As an object falls, its speed continues to increase, so its height above the ground decreases at a faster and faster rate. Ignoring air resistance, you can model the object's height with the function h equals negative 16t squared plus c. The height h is in feet, the time t is in seconds, and the object's initial height c is also in feet. Problem 5. Using the following object model. Nature. An acorn drops from a tree branch 20 feet above the ground. The function h equals negative 16t squared plus 20 gives the height h of the acorn in feet after t seconds. What is the graph of this quadratic function? At about what time does the acorn hit the ground? Consider what you know. You know the function for the acorn's height, and you know the initial height is 20 feet. You need the function's graph and the time the acorn hits the ground. So your plan to use a table of values to graph the function, then use the graph to estimate when the acorn hits the ground. Begin with the table, choosing some values for t to represent seconds after the beginning of the fall, 0, 0.5, 1, 1.5, and evaluating those using the equation and then graphing. So we see the right-hand side of a parabola here, beginning at a height of 20 and falling, looks like, to a height of 0, representing hitting the ground, just after 1 second. Graph the function using the first 3 ordered pairs from the table. Do not plot 1.5 negative 16 because height cannot be negative. This isn't an acorn that's going to leave a big impact crater and be 16 feet below ground level. The acorn hits the ground when its height above the ground is 0. From the graph, you can see that the acorn hits the ground after slightly more than 1 second. Your turn. Part A. In problem 5, suppose the acorn drops from a tree branch 70 feet above the ground. Now we may get an impact crater. The function h equals negative 16t squared plus 70 gives the height h of the acorn in feet after t seconds. What is the graph of this function? At about what time does the acorn hit the ground? And part B, a reasoning item. What are a reasonable domain and range for the original function in problem 5? Explain your reasoning.